Hi friends, good evening. Today we are going to discuss first session of mathematical methods in physics, that is vectors, right? So this vector concept is very important as we consider problems in electrodynamics and quantum mechanics, right? So first 2-3 lectures we focus in basic awareness of vectors, and then we will jump into advanced areas of vectors, right? In advanced areas we discuss different kind of coordinate systems, different operators using in vector calculus, and then different kind of integrals, line integral, surface integral, volume integral, and a different kind of theorems that is used to convert one form of integral into another form, right? This all we will discuss. Then today let us see what is a vector. What is a vector? A vector, as you know, is a quantity with both magnitude and direction, right? So in physics, most of the physical quantities are vectors: velocity, acceleration, force, momentum, angular velocity, angular momentum, etc. Right? See, so the need of a vector is, for example, if a body moving with a velocity 2 meters per second, right, along the x-axis, right? So how can I represent it? Suppose a body moving with a velocity 2 meters per second along the x-axis. Along the x-axis means I can use a unit vector I cap. So from the basic classes you studied I cap representing unit vector along x-axis, I cap representing direction of x-axis, and j cap representing direction of y-axis, and k cap represent the direction of z-axis. That will be studied in the lower classes, right? So here 2 meters per second I cap means these two representing magnitude of this vector. Magnitude means length of this vector, right? That length may be any physical quantity. That means velocity, acceleration, force, right? So these two representing the magnitude and this I cap representing the direction of this vector, right? So if suppose you have a vector, suppose this vector A, right, this is along east, then what is the vector along west? Is the same velocity vector with the same magnitude, but in the opposite direction we can represent as minus a, right? So from this concept, you know, if any vectors which are parallel and length is equal, if it represents same physical quantity also, they are equal vectors, right? Now let us see how we represent these vectors in Cartesian coordinate system, right? All right. See, here you look, one Cartesian coordinate system I have given here. Here this is x-axis, this is x-axis, and here it is y-axis, and here it is z-axis. Now you can represent like this. The basic unit vector along y-axis is j cap, that is this, right? This is j cap. Then this vector I can represent 2j cap, alright? Similarly, basic unit vector along z direction is k cap. So this vector representing 2k cap, right? And similarly, this along the x-axis, this is 2i cap. This is a Cartesian coordinate system which represent any physical quantity, right? maybe it is in velocity, a Cartesian coordinate system I am using to represent velocity, then this 2j cap represent velocity along y axis with magnitude 2. Alright? Alright. Now see, modulus of a vector, that also very important. What is a modulus of a vector? Here you can see a graph, right? See, here one unit I am taking as I cap. For example, see, look here, 1 unit, this is 2 unit, right? So 1 unit I am taking as I cap, this also I cap, so this x is equal to 2 I cap. Here we have 3 unit, right? Then this y is equal to 3 j cap, right? Now using triangle law, if two vectors representing two sides of a triangle, that means this is one side, right? OA, this is suppose B, right? OA represent from tail to head, AB representing from tail to head. So this is in the same order. So if two vectors representing in the same order two sides of a triangle, then the third side of the triangle, that is in the reverse order, right? That represent the resultant of two vectors. That is the triangle law you studied in lower classes. So what is the resultant here? 2 I cap plus 3 j cap, right? What is this 2 I cap plus 3 j cap represent? This represent the length of this vector, right? So how we can know this? Look here, this is I cap direction, this is j cap direction. What is the angle between them? 90 degree, because in mutually perpendicular system x and y are perpendicular to each other, right? Now by Pythagoras theorem, what you can write? This is square root of 2 square plus 3 square. What is 2 square plus 3 square? That is the modulus of this vector. That means for any vectors in Cartesian coordinate system, suppose if A is equal to 3 I cap plus 4 j cap plus 3 k cap, then what is the modulus of this vector? That is equal to square root of 3 square plus 4 square plus 3 square, right? So square root of coefficient of unit vectors in Cartesian coordinates represent the modulus of the vector, right? So that is very important. So generally, if two vectors representing a vector representing, suppose V representing xi cap plus yj cap, then what is mod V? That is square root of x square plus y square. Alright. Now moreover, see, look here. Suppose you have a vector like this. See, if this angle is theta, alright, this angle is theta. Now this x, this is the resultant r. Now using trigonometry also we can represent. What is x? X is equal to r cos theta. What is y? Y is equal to r sin theta. Then how we represent this r? This r is equal to, we can represent as r cos theta. This resultant is we can represent as r cos theta I cap plus r sin theta j cap. Now let us find the magnitude of this part. What is that? Square root of, right, r square cos square theta plus r square sin square theta. That is equal to square root of r square into sin square theta plus cos square theta 1. So you got the same r. Alright. So in Cartesian coordinate system with angle also we can represent. Generally in 2 dimension we can represent the position vector as r cos theta I cap plus r sin theta j cap. Alright. Alright. Now here I have given some vector operations as we discussed earlier. See, look here. Here one vector A given, that is from tail to head, here tail to head. Then the third side of the triangle is in the reverse direction, that is representing the resultant of these two vectors. That means this A, this B, this represent A plus B. Similarly, if this represent B, this represent A, this representing B plus A. Now, if a vector A is here, if you multiply with a scalar, its length is doubled, right? Its length is doubled, right? That means length doubled means the physical quantity not changing, but the magnitude changes by double, right? That only. Now, maybe by geometrical construction, suppose if you consider rain is falling vertically downward, right? Rain is falling vertically downward, right? So you may represent this direction as minus j cap. At the same time, wind is blowing in the opposite direction, alright? That you can represent wind velocity like this. Now that is minus I cap direction, right? Now obviously you know rain is falling vertically, at the same time wind is blowing in the opposite direction. That means this is vertically downward rain, and along east direction wind is blowing, then rain is coming like this, right? So with this direction, right? So the rain will come in this direction, right? So this is representing parallel to this side, so we can represent wind velocity in this direction, that is minus I cap. Then what is the resultant? Resultant is, this is VR minus j cap plus VW minus I cap, alright. So this kind of geometrical constructions also we can do with vectors, right? Alright. Now resultant of two vectors, right? What is resultant of two vectors? We want a basic expression for this, right? So here two vectors A and B I taken, right? So this is vector A, this is vector A, right? And this is vector B. As you know, using triangle law, this is the resultant. So to find out this resultant, I am considering a construction, right? Like this. Now this is B, then I can write this as B cos theta, right? Using trigonometry, and this I can write as B sin theta, alright. Now as I am considering the whole triangle, that means triangle ONB, right? Consider triangle ONB. What I can write? I can write base square plus altitude square is equal to hypotenuse square. What is hypotenuse square? R square. What is base square? That is A plus B cos theta the whole square. That means A plus B cos theta the whole square, right? Plus altitude square is B sin theta the whole square, alright? Alright. Now R square is equal to A square plus B square cos square theta plus, right? And 2AB cos theta, right? 2AB cos theta plus B square sin square theta, alright? B square sin square theta. Now I can take out A square here. From this and this I can take B square out. Then A square plus B square I am taking out. What is remaining? Cos square theta plus sin square theta plus 2ab cos theta. 2ab cos theta. Alright? Alright. Now, if I find out the resultant R, that R is equal to, this part is 1, right? And resultant is equal to a square plus b square plus 2ab cos theta. Alright? So, if two vectors A and B acting with an angle theta, then the resultant expression is this, right? Resultant is root of a square plus b square plus 2ab cos theta. So, let me write this expression here again. See, R is equal to root of a square plus b square plus 2ab cos theta. Alright. Now, the important thing is, you know that if one vector A, say A and B are two forces, I am considering as two forces, then A in this direction, B also in the same direction. Then what is the angle between A and B? 0, right? Then if this angle is 0, cos0 is 1, then what is R? Square root of a square plus b square plus 2ab. Cos0 is 1. Then a plus b the whole square, that is equal to a plus b, right? So, if two forces are acting in the same direction, the forces will be added, right? Already we know, right? Similarly, if A and B acting in the opposite direction, what happens? Then the forces will be, one force is acting from here, another force is acting, then bigger force minus lower force, that is the resultant. How we got that result? If these are acting in the opposite direction, then what is the angle here? Theta is 180. Then what is cos 180 minus 1? Then what is the resultant? Resultant will be a square plus b square plus 2ab into minus 1. Right, that is a minus b the whole square. Then what is the resultant? A minus b. Alright. So, this kind of calculations are possible using resultant of two vectors. Right. Now, in the next class we will study dot product, cross product, and then we will come into different kind of problems. Okay. Thank you.